me, your hand is raised. You want
Yes,
to make an announcement?
Yes, sir. It's those who can't see the slides. I wasn't also able to see, so I left the meeting and joined again. Now I can see, so they can try that.
Okay, so your tutor is saying that if you cannot see the slide, you can leave the meeting and join again. Okay, so the tutor is saying you can leave the meeting and come back, and then you would hopefully see the slide.
Yes, it's true.
All right, so let's begin. So today we're looking at deductive reasoning. I, I, I must have mentioned in our last meeting that today's meeting is it's normally the longest and let's say the toughest of the semester. So I had explained that the first half of the semester was a preparation for the second. So in the first half of the semester, we studied concepts in language and meaning. We studied statements that are not logical. We learned to identify passages that are argumentative or not. So now it is time to study arguments. So this is the introduction or the beginning of the second half of the semester. And to begin studying arguments, first of all, we have to say that arguments are also called reasoning or syllogisms. The three terms are used interchangeably. So when you refer to arguments, you're also referring to reasoning and or syllogism. Now, the two major categories of reasoning or arguing are deductive and inductive. So whenever you are making an argument, it is either a deductive argument or an inductive one. It has to be one of the two. Anything outside the two is a fallacy, or we just call it rhetoric. We also have causal reasoning, but it's a form of inductive reasoning. We'll see that later. Let's begin with deductive reasoning, which we are doing today. Now, deductive reasoning, also called deductive argument or deductive syllogism. Now, this is reasoning in which the relationship between the premises and the conclusion is a logical relationship. The relationship between the premises and the conclusion is a logical relationship. As a result of this, it is reasoning that permits only one conclusion. The relationship between the premises and the conclusion is a logical relationship. Now, when you say 2 plus 2 equal to 4, the relationship is logical. And because of the logical nature of the relationship, it can only lead to one conclusion. That's why 2 plus 2 can only lead to 4. You can't say 2 plus 2 is 5 or 2 plus 2 is 7. So because of the logical nature of the relationship between the premises and the conclusion, the premises usually lead to one conclusion. So that tells you that deductive reasoning is gotten, derives from mathematics. Example, all men are mortal, Kofi is a man, therefore Kofi is mortal. All men are mortal, Kofi is a man, therefore Kofi is mortal. Now, when you say all men are mortal, and you also say that Kofi is a man, automatically you are saying Kofi is mortal. Now, you cannot change or modify the conclusion. You can't say, for example, Kofi is immortal or a fire cabinet is mortal. Now, when you look at premise 1 and 2 and the conclusion, you see that there are three terms. We have men, mortal, and Kofi. Men, mortal, and Kofi. If you look at premises 1 and 2, the concept of men occurred twice. The concept of men occurred in premise 1. Men also appeared in premise 2. Now, mortal occurs in premise 1, but mortal didn't occur in premise 2. Kofi occurred in premise 2, but it is not in premise 1. So between premises 1 and 2, men occurred twice, mortal is once, Kofi is once. So what you need for the conclusion is to just get out those ones that occurred only once, bring them down to form the conclusion. So you have Kofi once, mortal once. You bring Kofi and mortal down to form the conclusion. And the nature of the relationship between premises 1 and 2 automatically tell you which one is the subject of the conclusion and which one is the predicate. So you know from premises 1 and 2 that Kofi will be the subject of the conclusion and mortal will be the predicate. So you can see that it's simply a mathematical operation which you cannot do anything about. Now let's look at the reference and attribute classes. We want to understand why deductive arguments work like mathematics. To do that, there are certain concepts we need to understand clearly. Okay. So first of all, we have two parts of the sentence, like the subject and the predicate. We'll have the reference class, and then we'll have the attribute class. Now, in English grammar, you already know the subject and the predicate, but we don't call them the subject and the predicate in logic. Now, when we were doing definitions, we called the subject the definiendum and the predicate the definients. Now we're doing arguments. The subject is called the reference class. The predicate is called the attribute class. There are technical reasons why we are using those terms, reference and attribute classes. Now, so for example, all men are mortal. All men is the reference class, and mortal is the attribute class. The reference class is that to which the sentence refers, whilst the attribute class is that part of the sentence that is attributing something to or saying something about the reference class. So we call it the reference class because the rest of the sentence refers to it. The rest of the sentence refers to it. That's why we call it the reference class. And then the attribute, the rest of the sentence, which we call the attribute, is attributing something to the reference class. So that's the technical reason for those terms. Okay. Now, we have two types of reference classes. We have the finite and infinite. The finite and infinite. Reference class can be finite and infinite. The infinite reference class refers to all members or no members of a class. The infinite reference class refers to all members or no members of a class, either 100% or 0%. Example, all men, no man, any man. All men, no man, any man. It is a class of uncountable items. It is a class that contains uncountable items. You can't count the items in the class, in that class. For instance, you can't count all men. You can't count no man. You can't count any man. They are all uncountable items. On the other hand, finite reference class refers to countable and particular members of a class, anything between 0% and 100%. That's the finite reference class. So example, some men, 80% of men, 5 men, all the men. Now remember that all the men is different from all men. Now, all men contain some countable items. items, but all the men are countable. For instance, all the men in this class, all the men in this university, all the men in this hostel, all the men in this town, they are all countable. So all the men are countable, but all men are not countable. Then few men, almost all the men. So all these are countable items. So in summary, the infinite reference class contains uncountable items. The finite reference class contains countable items. Then there is a distinction between universal and particular statements. Universal and particular statements. Statements containing infinite reference class are called universal statements, whilst those containing finite reference classes are called particular statements. So those statements containing infinite reference class, which is uncountable items, are universal statements. And those ones containing the finite reference classes, which contain the countable items, are particular statements. Example of universal statements: all men are mortal. All men are mortal. It's a universal statement. Example of particular statements: some men drink alcohol. Some men drink alcohol. Particular statements. So you have the universal statements, statements containing the infinite reference class, and you have the particular statements, statements containing the finite reference class. Now let's relax with a little exercise before we go ahead. Which statements are universal and which are particular? Which statements are universal and which are particular? This table is three-legged. This table is three-legged. Someone should answer it quickly. This table is three-legged. Is it universal or particular?
Particular.
Peter. Okay, particular. The second one. The second one. Tables can be Saturn. Tables can be Saturn. Peter. Tables can be Saturn.
Universal.
Universal.
It's universal.
Yeah. James and Mary passed the examination. Okay. James and Mary passed the examination. James and Mary passed the examination.
Particular.
Oh, sure. Okay. And then all visitors should be treated with respect. All visitors should be treated with respect.
Universal.
Universal.
Universal. Okay. So bring down your hand. Let's go ahead. Now let's look at the subject of validity. Akoso, I'll bring down your hand, but watch out for the next questions. Unless you wanted to ask a question. Akoso, you wanted to ask a question?
No, please, it's okay.
All right. So let's look at the subject of validity. Now, validity is a very special issue when we're talking about deductive arguments. Validity. So if you've been following the lectures up till now, then you should be happy because you are likely to pick up the rest of the class. Now let's talk about validity. An argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. An argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. Okay. So when we were talking about 2 plus 2 equals 4, we were saying now 2 and 2 are the premises. 2 plus 2 premises, and then the conclusion is 4. So the premises 2 plus 2 make the conclusion 4 necessary, and the conclusion 4 follows with certainty. All valid arguments are called so inductive arguments are strictly not valid. All valid arguments are deductive arguments. All valid arguments are deductive arguments. Inductive arguments are strictly not valid. Deductive argument is a purely mathematical argument. It's purely mathematical. The relationship between premises and the conclusion is logical. So you can refer back to the example. We have already said that in the example, is a operation and it cannot lead to any other conclusion apart from Kofi is mortal. Okay, so that's lead to only one conclusion. Now let's compare it to an inductive argument. Now this is an example of an inductive argument. Inductive argument, premise 1, 95% of men are honest. Premise 2, Peter is a man. Conclusion, Peter is honest. So premise 1 tells us that 95% of men are honest. So that implies that 5% may not be honest. We're only sure that 95% are honest, but we're not sure of the other 5. And then premise 2 says Peter is a man. So now we are faced with coming up with a conclusion. And the conclusion is Peter is honest. But then this conclusion meets with some resistance. You can see that more than one conclusion is possible. Possible conclusion 1, Peter is honest. Possible conclusion 2, Peter is not honest. Now, we were not told if Peter is among the 95% of honest men, of men that are honest. So as it stands, Peter could be among the 95% that are honest, or Peter could be among the 5% that were not sure of their honesty. So when you say Peter is honest, it needs to be taken with a pinch of salt, because it's not really that's not the only possible conclusion. There are more than one possible conclusion. Peter is not honest is a competing legitimate conclusion. This is an example of an argument that leads to more than one possible conclusion. So any argument that leads to more than one possible conclusion is an inductive argument. So you know inductive arguments by asking yourself or confirming if the argument leads to more than one possible conclusion. Now, this thing about one conclusion or more than one conclusion is not in the required textbook. I had to get it from another textbook so that you can better understand. The textbook at the Kingdom Bookshop beside the BAM library, the red and black critical thinking, understanding and applying critical thinking. I think it's at both main campus and city campus. So it helps you quickly understand how to distinguish deductive from inductive arguments. So that's a yardstick for determining both kinds of arguments. Without it, it's not so easy. Sometimes it just takes unnecessary time to know if an argument is deductive or inductive. Just ask yourself if the argument leads to only one conclusion, or it leads to more than one possible conclusion. That tells you if an argument is deductive or inductive. Now, in order to understand deductive arguments further, we need to work with what we call conditionals, the hidden condition if and then. Whenever you make a statement containing if and then, we call it a conditional statement. Whenever you make a statement containing if and then, we call it a conditional statement. And there are two ways of looking at arguments. You could look at arguments in categorical ways, conditional ways. Now, all arguments have hidden conditionals. So even if you see them in their categorical form, you can compare them to their form. All men are mortal. That's a categorical statement. You can convert it to a conditional statement. Now, the conditional statement is, if something is a man, then it is mortal. If something is a man, then it is mortal. That's the conditional version. All men are mortal is categorical. If something is a man, then it is mortal is conditional. So those are the two ways of looking at arguments. Now, it is only the major premise that you can convert from a categorical to a conditional statement. Like in the example we did, the major premise is premise 1. So now change the categorical statement of premise 1 to a conditional statement. Premise 1, if something is a man, then it is mortal. Premise 2, Peter is a man, therefore Peter is mortal. So these are the two ways of looking at it. You can convert the major premise in an argument into a conditional. And it is only the major premise that you can convert to a conditional. Normally, you cannot convert the minor premise. By the minor premise, I mean premise 2, Peter is a man. Now, Peter is a man, you can't convert it to a conditional. Okay. Now, let's replace the words with symbols. Replacing the words with symbols, first of all, let's look at the categorical version. All men are mortal. All A's are B's. All men are mortal. All A's are B's. Peter is a man. X is an A. Peter is mortal. X is a B. Now, so men, we have three concepts. We have men, mortal, and Peter. So we represent the men with A. We represent the mortal with B, and then Peter with X. So all men are mortal. All A's are B's. Peter is a man. X is an A. Peter is mortal. X is a B. So we're going to be working a lot with symbols. And when we work with symbols, we convert the symbols to words. Now let's look at the conditional version. If something is a man, then it is mortal. Peter is a man, therefore Peter is mortal. So to convert them to symbols, if A, then B. If A, then B. X is an A, therefore X is a B. X is an A, therefore X is a B. Or you can say if A, then B. A, therefore B. Okay. Now, so the last concept we need to understand before we start working with deductive arguments is the difference between the antecedents and consequence. Antecedents and consequence. So I can notice that there are some people in the class having the other link. So we need to inform those in the other platform to come over here because we are not using that link. So I think this is an announcement we should have put out, that the other link is not going to be used. All right. So let's look at the difference between antecedents and consequence. Now let's remember the distinction between the reference class and the attribute class. If we restate any categorical proposition as a conditional statement, the reference class becomes the antecedent and the attribute class becomes the consequent. Now, remember we're working with both categorical and conditional statements. And normally, for you to work better with an argument, it's better to convert the categorical to the conditional. when you look at an argument in a conditional form, it gives you a clearer picture of what you want to do. Okay. So we're saying that whenever we restate any categorical proposition as a conditional statement, the reference class becomes the antecedent and the attribute class becomes the consequent. Now, I was saying that the major premise is that premise that can be converted from a concept. When you convert the major premise to a conditional statement, the first part, the if part, the first part, the if part, is the antecedent. And then the second part, the then part, is the consequent. So example, or A are B, or if A then B, or A are B, or if A then B. Now, if A, the if part, which is A, is the antecedent, and then the then part, which is B, is the consequent. So the reference class, in this case A, is the antecedent, and then the attribute class, in this case B, is the consequent. So A is the antecedent and B is the consequent. Or A are B, or if A then B, A is the antecedent and B is the consequent. And that applies to only major premises, the major premise. That premise you can convert to a conditional. Remember, you cannot convert the second premise to a conditional. It's only the major premise, in this case, premise 1, that you can convert into a conditional. That's the same premise where you can talk about antecedents and consequence. You don't talk about antecedents and consequence in the second premise. It doesn't apply there. So A is the antecedent and B is the consequence. So any statement referring to A will be either affirming or denying the antecedent. And any statement referring to B will be either affirming or denying the consequent. Any statement referring to A will be either affirming or denying the antecedent. And any statement referring to B will be either affirming or denying the consequent. Let's see examples. X is an A, affirms the antecedent. X is not an A, denies the antecedent. X is a B, affirms the consequent. X is not a B, denies the consequent. So we have said that all A are B, or if A then B, A is antecedent. So any of these statements referring to A or B is either affirming or denying the antecedent or affirming or denying the consequent. X is an A, affirms the antecedent. X is not an A, denies the antecedent. X is a B, affirms the consequent. X is not a B, denies the consequent. Now, let's begin with affirming the antecedent. All A's are B's. X is an A, therefore X is a B. So you can see that X is an A, affirms the antecedent. X is an A, affirms the antecedent. So because of that, we say that the whole argument affirms the antecedent. This is an example of an argument that affirms the antecedent. You don't just say X is an A, affirms the antecedent. You say that the whole argument affirms in order to reach its conclusion. Find the antecedent. All A's are B's. X is not an A, therefore X is not a B. So you can see that X is not an A, denies the antecedent. For that reason, you say that the whole argument denies the antecedent. And this is an example of an argument that denies the antecedent. Affirming the consequent. All A's are B's. X is a B that affirms the consequent. Therefore, X is an A. So For that reason, we said that the whole argument affirms the consequent. And this is an example of an argument that affirms the consequent in order to reach its conclusion. Denying the consequent. All A's are B's. X is not a B. So X is not a B denies the consequent. So for that reason, we say that the whole argument denies the consequent. And this is an example of an argument that denies the consequent in order to reach its conclusion. Now let's look at the rule for deductive reasoning. We have just one rule for deductive reasoning. We only affirm the antecedent or deny the consequent in order to reach a valid conclusion. We only affirm the antecedent or deny a valid conclusion. Any other operation will make the argument lose its validity. Any other operation will make the argument lose its validity. Example, all A's are B's, X is an A, affirms the antecedent. X is an A, affirms the B. We say that affirms the second example is B is not a antecedent. X is not a B. We say it is not a valid argument. Now let's put it in words. All Ghanaians are Africans. Peter is a Ghanaian, which affirms the antecedent. Therefore, Peter is an African. We say it's a valid argument because it affirms the antecedent. Now, the second example, all Ghanaians are Africans. Peter is not a Ghanaian, which denies the antecedent. Peter is not an African. We say it's not a valid argument because it denies the antecedent. Okay. So the rule is that we can only affirm the antecedent. We can't deny the antecedent. If you affirm the antecedent, it will lead you to.
I thought she died. When I saw that part, I was like, wow, I'm waiting,
but
I'm
if
waiting
you
for
not lead you to a valid conclusion. Okay, so let's look at the technicality. Someone's hand is raised.
Esther. Esther, please, I'm after you.
Please mute your speakers. Your microphones, please.
Yeah, so the person whose hand is raised, do you have a question or can you withhold your question until we are done with this particular section? Okay, so going back to the deductive rule, to the rule for deductive reasoning, we can or deny the consequent in order to reach a valid conclusion. Any other operation will make the argument lose its validity. So we saw this example. This is an argument that affirms the antecedent, X is an A. We said it's valid. The second one denies the antecedent, X is not an A. We say it's not valid. Now, putting it in words, all Ghanaians are Africans. Peter is a Ghanaian, affirms the antecedent. So Peter is an African. So we say it's a valid argument. The second example denies the antecedent. Peter is not a Ghanaian. Therefore, Peter is not an African. We say it's not a valid argument. Now, why is it so? Now, since this is a rule for deductive reasoning, we can now ask ourselves why the second argument is wrong and the first argument is correct. So what we have done is to come up with a technicality. Now, this is a technicality. The consequent is always a larger class of denotations or members compared to the antecedent. The consequent usually contains the denotations of both the antecedent and possibly more. So the idea is that the consequent is normally a larger class of items compared to the antecedent. In this case, the consequent Africans contains more members than the antecedent Ghanaians. So when you deny something of membership in a smaller class, you have not denied it of membership in a larger class. Okay, even before that, when you affirm something of membership in a smaller class, the class of Ghanaians, if you say Peter is a Ghanaian, then automatically it is also part of the larger class, Africans. But if you deny that Peter is a Ghanaian, if you say Peter is not a Ghanaian, as a way of denying that he's an African, then that's not a valid argument. Because Africans, the class Africans is larger than the class of Ghanaians. If you say something is not in the class of Ghanaians, and because of that, you conclude that it's not in the class of Africans, it is not a purely logical move. It's not what do I call it? It's not a self-assured move, because there are other parts of Africa apart from the Ghanaian class. So if you say something is not in the Ghanaian class, as a way of saying it's not in an African class, it may turn out that it is in another part of Africa. Okay, so let's look at two diagrams. Now these are two boxes. The bigger box is the box of consequence. The smaller one is the box of antecedents. The consequence is usually a larger class of items when compared to the antecedent. The antecedent class is usually smaller than the consequent class. Not only that, also the antecedent class is usually inside the consequent class. The antecedent class is not only smaller than the consequent class, but it's also inside the consequent class, somewhere inside. When you say all Ghanaians are Africans, all Ghanaians are Africans, you are not only saying that Ghanaians are accommodatable in Africans, but you are also saying that everything in the Ghanaian class is inside the African class. Everything in the Ghanaian box is inside the African box. All Ghanaians are Africans. And you're also implying that the box containing Africans could be larger than the box containing Ghanaians. So what you are sure is that the box containing Africans is big enough to accommodate the box containing Ghanaians, and logically speaking, it can accommodate more. Okay, so these are two boxes, the African box and the Ghanaian box. So you can see that the Ghanaian box is small inside the African box. When you say all Ghanaians are Africans, you can see the Ghanaian box is inside there. If you say Peter is a Ghanaian, which affirms the antecedent, therefore Peter is an African, you are correct. You are correct, because everything in the Ghanaian box is also in the African box. So Peter is a Ghanaian, therefore Peter is an African is a valid argument. But if you say Peter is not a Ghanaian, therefore Peter is not an African, that is an invalid argument. Because denying Peter of being in the Ghanaian box does not matter than being in the African box. So saying that Peter is not in the Ghanaian box is not enough to conclude that he's not in the African box. He could be in any other part of the African box apart from the Ghanaian box. So the argument Peter is not a Ghanaian, therefore Peter is not an African, is invalid. You can see how it works. If you say Peter is a Ghanaian, therefore Peter is an African, it's valid. But if you say Peter is not a Ghanaian, therefore he's not an African, it's invalid. That's why the deductive rule says you only reach a valid conclusion by affirming the antecedent. If you deny the antecedent, you will not reach a valid conclusion. So let's go back to the technicality. The consequent is always a larger class of denotations or members compared to the antecedent. The consequent contains the denotations of both the antecedent and possibly more. The consequent Africans contain more members than the antecedent Ghanaians. When you deny something of membership in a smaller class, you have not denied it of membership in a larger class. But when you deny something of membership in a larger class containing all the members of a smaller class, you've automatically denied it membership in a smaller class. So that one is modus ponens. We're coming to that. Okay, so based on this technicality, we can look at 4 kinds of deductive arguments. But let me see, someone is raising his hand. Oduro. I saw Oduro raising his hand, but he has brought it down. Felicity's hand is also raised. Felicity, do you have something to ask? Okay.
I don't understand. For example,
Understand?
all men are liars. All men are liars. Can liars be consequent?
Can you say all men are lions?
All men are liars. Liars.
Okay, all men are liars.
Yeah.
Yeah, when you say all men are liars, you are implying that liars is a larger category than men.
Okay, so the consequence has to be larger than the antecedent.
Yeah, the consequence is logically larger. The consequence is we say it is logically larger, than the antecedent. So when you say all men are liars, you are implying that
thank you very much.
Liars can also, yeah. So when you say all men are liars, you are implying that liars can also contain more than men, more than all men.
Thank you.
Okay. So 4 kinds of deductive argument. The technicality is going to help us understand the 4 kinds. The first kind, modus ponens, an argument that affirms the antecedent. So modus ponens is an argument that affirms the antecedent. All A's are B's. If something is an A, then it's a B. X is an A, affirms the antecedent. X is a B. All Ghanaians are Africans. Peter is a Ghanaian, affirms the antecedent. Peter is an African. So we say it's a valid argument. Modus ponens is a valid argument because it affirms the antecedent. Then the fallacy of denying the antecedent. The fallacy of denying the antecedent. All A's are B's. X is not an A. Therefore, X is not a B. All Ghanaians are Africans. Peter is not a Ghanaian, which denies the antecedent. Therefore, Peter is not an African. So we say it's not a valid argument because Peter could possibly be a Cameroonian or a South African. So you cannot reach a conclusion that Peter is not an African by saying Peter is not a Ghanaian. Peter is not a Ghanaian is not a sufficient proof for Peter is not an African. So remember, the whole idea is about proofs, validity. The whole idea is about validity. To have validity requires proof. It has to be proven. Anything that cannot be proven falls short of validity. So we've seen these 2 boxes, consequence and antecedents. The consequent box is larger than the antecedent box. The African box is larger than the Ghanaian box. Now, modus tollens. Modus tollens. X is not a B, which denies the consequent. Therefore, X is not an A. Or if A, then B, not B, therefore not A. So we said this is a valid argument because it denies the consequent. Remember, a rule for deductive reasoning is that you either affirm the antecedent or deny the consequent. So denying the consequent is valid. And we call it modus tollens. Modus tollens. let's put it in words. All Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. We said it's a valid argument. All Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. You can put it in a conditional. If Michael is a Ghanaian, then he's an African. Michael is not a Ghanaian. Michael is not an African, therefore Michael is not a Ghanaian. Now, so we can look at it in the diagram, in the boxes. Michael is not an African, therefore Michael is not a Ghanaian. So let's go back to the two boxes. We said all Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. We said it's valid. Why is it valid? If you say Michael is not an African, not in anywhere in the larger box, and that includes the Ghanaian box. So when you say Michael is not an African, therefore Michael is not a Ghanaian, it's a valid argument. So denying the consequent leads you to a valid conclusion, and denying the consequent is what we call modus tollens. Okay, let's look another example. All those studies in the Department of Physics are enrolled at the University of Ghana. Kelvin is not enrolled at the University of Ghana, so Kelvin is not studying in the Department of Physics. Now, let's imagine that there's a debate about whether Kelvin is in the Department of Physics. Some people are saying that Kelvin is in the Department of Physics because they've seen him in physics very often. Maybe some people see Kelvin in the Department of Physics almost every week, so they conclude he's in the Department of Physics. Some other people say he's in Department of Chemistry because they see him in chemistry. So one group is arguing that Kelvin is in the Department of Physics. Another group is arguing that Kelvin is in chemistry. And then someone decides to consult the registry to find out if Kelvin is enrolled at the University of Ghana, or to find out if Kelvin is registered at the registry for physics or chemistry. And then those at the registry conduct an audit of Kelvin. And they see that he's not in physics, he's not in chemistry, and he's not even at University of Ghana. So the registry gives the feedback or announces that Kelvin is not enrolled at the University of Ghana. So what happens to the argument about whether he's in physics or chemistry? The argument disappears. Once you can prove that Kelvin is not University of Ghana, then he cannot be in the Department of Physics. And he cannot be in the Department of Chemistry. If we are to put the box containing Department of Chemistry here, it will be another small box inside University of Ghana box. So if he's not in the University of Ghana, then he cannot be in any of those small boxes. So this is the argument of, again, all those studying in the Department of Physics are enrolled at the University of Ghana. Kelvin is not enrolled at the University of Ghana, so Kelvin is not studying in the Department of Physics. If you can deny somebody something of membership of the consequent, automatically you have denied it of membership of the antecedent, because the consequent is larger than the antecedent, and the whole of the antecedent is inside the consequent. So if something is not in the consequent, it cannot be in the antecedent. Let's look at the fallacy of affirming the consequent. Fallacy of affirming the consequent. Or A and B, X is a B that affirms the consequent. Therefore, X is an A. We said it cannot lead to a valid conclusion. Let's put it in words. All Ghanaians are Africans. All Ghanaians are Africans. George is an African, therefore George is a Ghanaian. All Ghanaians are Africans. George is an African, therefore George is a Ghanaian. Or if George is a Ghanaian, then he's an African. George is an African, therefore George is a Ghanaian. So all Ghanaians are Africans. George is an African, therefore George is a Ghanaian. Now, can you look at the box containing Africans, the African box and the Ghanaian box? All Ghanaians are Africans, because you can see that the Ghanaian box is squarely inside the African box. If you say that George is not an African, then it means that George is nowhere in the African box, and that includes if you say George is not an African, then automatically he cannot be a Ghanaian, because everything in the Ghanaian box is inside the African box. So denying something of membership of the consequent denies it of membership of the antecedent. But if you say that George is an African, therefore George is a Ghanaian, being an African is not enough proof to show that someone is a Ghanaian. If you say that George is an African, George is a Ghanaian, it's invalid. Because merely being an African is not enough reason to conclude that a person is a Ghanaian. If somebody is an African, he could be any of the other countries in Africa. So that's why we say that affirming the consequent is not a valid argument. Affirming the consequent is an invalid argument. It will lead you to an invalid conclusion. So this is the explanation. The consequent Africans contains a logically larger category of denotations compared to the antecedent Ghanaians. So the fact that George is an African does not necessarily mean that he's a Ghanaian. He may be a South African or a Cameroonian. If we affirm the consequent, we are not sure we can affirm the antecedent. In short, if we affirm the consequent, it can land us in the same uncertainty that we saw in the fallacy of modus ponens, the fallacy of denying the antecedent. So denying the antecedent or affirming the consequent always lead us to invalid conclusions because they don't provide enough reasons for the conclusion. Now let's look at another form of the fallacy of affirming the consequent. Another form of the fallacy of affirming the consequent. All A are not B. X is not a B, therefore X is an A. Affirming the consequent. All A are not B. X is not a B, therefore X is an A. And at first, when you look at this, you think that it denies the consequent because it is X is not a B. So when you see X is not a B, naturally that is to deny the consequent. But when you check the major premise, which is the first premise, all A are not B, and check again the second one, X is not a B, then you begin to get a different picture. Now, all A are not B is denying the consequent. All A are not B is denying the consequent. The major premise is denying the consequent. And then the minor premise is also denying the consequent. When you have two negatives, they combine to give you a positive. When you have two negatives, they combine to give you a positive. So all A are not B, X is not a B. X is not a B is actually affirming all A are not B. X is not a B is affirming all A are not B because both of them are negatives. So the second negative is affirming the first negative. So that is another version, another form of the fallacy of affirming the consequent. So in case you see this in an examination or a continuous assessment, you know what it is so that you don't get caught by surprise. So let's put it in words. All human beings are not good. X is not a good, therefore X is a human being. Shadrach, your hand is raised.
Sir, please, so I want to know if that statement. I want to know if that statement was valid. That means it is valid or it's not valid. I want to know.
No, according to the rule for deductive reasoning, affirming the consequence. The question is whether affirming the consequence is valid according to the rule of deductive reasoning. So once you've confirmed that it affirms the consequence, is affirming the consequence valid or invalid?
Invalid.
Yeah, so we said affirming the consequence is invalid. So if you thought that this is denying the consequence, then you would have picked valid. But because you have found out that it is not denying the consequence, it's rather affirming the consequence, then you know it is invalid.
Okay.
You have to be ready
sir.
for
Thank you.
surprises in your exams and your continuous assessments. Yes. All right. So we're putting it in words. All human beings are not goats. Sydney, your hand is raised.
Sir, so I wanted to ask for the second part of the slides. Does it mean that if X is an A, then X is not a B? Is that affirming the antecedent?
X is an A.
Yes.
Or X is not a B. Which one?
So if
because
X,
both
if
of
X
them
is,
are
if,
doing different things. Now, X is an A, affirms the antecedent. The X is not a B, denies the consequent. So I wanted to know the one you are referring to.
I was referring to the second one. If X is an A, then it is not B.
Yeah, if X is an A affirms the antecedent, we've been using A as antecedent and B as consequent. So X is an A will be affirming the antecedent. And then X is a B affirms the consequent. X is not a B, denies the consequent.
Okay.
Yeah, so all human beings are not goats. All human beings are not goats. X is not a goat. X is a human being. All human beings are not goats. X is not a goat. X is a human being. So you can see that there are two negatives. There's a negative in premise 1. There's a negative in premise 2. The two of them will give you a positive. So that means that this argument affirms the consequent. It affirms the consequent, and it cannot be correct. So then you can ask yourself, why is this argument not correct? When you look at it closely and use your common sense, then you begin to see why it's not correct. So if you say all human beings are not goats, which is correct, and then you say X is not a goat, therefore X is a human being, then you begin to see a weakness. The fact that X is not a goat doesn't mean that X is a human being. Remember that the fact that all human beings are not goats doesn't mean that human beings are the only animals that are not goats. The fact that all human beings are not goats doesn't mean that human beings are the only animals that are not goats. So saying X is not a goat to conclude that X is not a human being, it doesn't provide sufficient reason for the conclusion. So that's why we say that affirming the consequent will always lead you to an invalid conclusion. So the explanation. Now, not being a goat is a logically larger category than all human beings. not being a goat, is a logically larger category than all human beings. So, like I told you, the fact that all human beings are not goats doesn't mean that human beings are the only animals that are not goats. So, the fact that X is not a goat does not necessarily make X a human being. The fact that X is not a goat doesn't necessarily make X a human being. X could as well be a cat, giraffe, or tiger. So that's the end of the affirming the antecedent, denying the antecedent, affirming the consequent, and denying the consequent. We saw that affirming the antecedent is modus ponens, denying the antecedent is the fallacy of denying the antecedent. Affirming the consequent is a fallacy, and then denying the consequent is modus tollens. Now that means that out of the four of them, two are correct, two are not correct. Modus ponens and modus tollens are correct. The other two are not correct. Fallacy of denying the antecedent is not correct. Fallacy of affirming the consequent is not correct. So modus ponens and modus tollens are the first two kinds of deductive reasoning. Now we're going to look at the fourth kind of deductive reasoning. We call it the hypothetical syllogism. And then the fourth one will be the disjunctive syllogism. We're coming to that. So hypothetical syllogism, an argument where the consequent of an initial or first premise becomes the antecedent of a second or subsequent premise. The consequent of an initial or first premise becomes the antecedent of a second or subsequent. So the consequent of one premise becomes the antecedent of the next premise. The consequent of any premise becomes the antecedent of the next one. And then subsequent premises feature the consequence of their predecessors as their antecedent. The conclusion pairs the very first antecedent and the very last consequent. The conclusion pairs the very first antecedent and the very last consequent. So let's look at it. Now we said the consequent of one premise becomes the antecedent of the next one. Or A are B, or B are C. So you can see that the consequent of the first premise has become the antecedent of the next one. That's how you know a hypothetical syllogism. All A are B, all B are C. You can also say all C are D, all D are E, all E are F. That's the technicality of a hypothetical syllogism. The consequent of any premise becomes the antecedent of the next premise. You can put it in a conditional form. If A, then B. If B, then C. If C, then E. Sorry, if C, then D. If D, then E. If E, then F. If F, then G. If G, then H, down to Z. Now, the conclusion usually pairs the very first antecedent and the very last premise. The conclusion usually pairs the very first antecedent and the very last premise. So all A are B, all B are C, therefore all A are C. Or if it goes down to Z, all A are B, all B are C, all C are D, all D are E, all E are F, all F are G, all G are H, down to Z. The conclusion will be all A are Z. Let's put it in words. All Ghanaians are Africans, all Africans are human beings. Therefore, all Ghanaians are human beings. You can see that the consequent of the first premise has become the antecedent of the second one. All Ghanaians are Africans, all Africans are human beings. Therefore, all Ghanaians are human beings. So you just bring together for the conclusion the very first antecedent and the very last consequent. Look at the conditional. If you're a Ghanaian, then you're an African. If you're an African, then you're a human being. Therefore, if you're a Ghanaian, then you're a human being. So the explanation, we notice that the consequent of the first premise, which is B, becomes the antecedent of the second premise. And the antecedent of the second premise, which is the consequence of the first premise, leads us to a new party, which is C, as the consequent. Any additional subsequent premise will typically feature the consequent of its predecessor as its antecedent, so that it is linked conditionally to a fresh party. So, how you add more premises is by simply bringing down the consequent of the last premise and then linking it to a fresh party. Now let's look at two fallacies of hypothetical syllogism. Two fallacies of hypothetical syllogism, or we call them two hypothetical fallacies. Two hypothetical fallacies. The first fallacy, all A are B, all B are C, therefore all C are A. All A are B, all B are C, therefore all C are A. Now instead of the conclusion saying all A are C, it says all C are A. The conclusion reverses the terms. Or look at the conditional. If A, then B. If B, then C. Therefore, if C, then A, which doesn't make sense. Now let's put it in words so that you can see the contradiction. All Ghanaians are Africans. All Africans are human beings. Therefore, all human beings are Ghanaians. So here you can see why it is wrong. Therefore, all C are A. It's a fallacy. Now let's look at the second hypothetical fallacy. All A are C, all B are C, therefore all A are B. So this one just messes up the whole terms completely. All A are C, all B are C, therefore all A are B. This argument is telling you to believe that A and B are the same because each of them is equal to C. A and B are the same because each of them equates to C, but it is not necessarily true. Let's put it in ways so that you can see the contradiction. All Ghanaians are Africans. All Kenyans are Africans. Therefore, all Ghanaians are Kenyans. So you can see why it is not true. The fact that Ghanaians are Africans and Kenyans are also Africans doesn't mean that Ghanaians are Kenyans. You don't argue that A and B is the same because each of them is or because each of them is a C. The fact that each of them is a C doesn't mean that they are the same. It can be true by accident. Ghanaians are human beings, Africans are human beings, therefore Ghanaians are Africans. All Ghanaians are human beings, all Africans are human beings, therefore all Ghanaians are Africans. So all Ghanaians are Africans is true, it's a true conclusion. But we did not get that conclusion from the premises. We know that the conclusion is true because we know that before seeing this argument. But there's no way you can know from this argument that all Ghanaians are Africans. Because the premises were improperly set up. So we say that the conclusion is only accidentally true. It is not true because of the premises. Now let's look at disjunctive syllogism. A syllogism where there is a disjunctive, either or. Any either or statement is called a disjunctive statement. When we affirm something of any of the disjunctive items, then we automatically denied it the other disjunctive part. When we affirmed something of any of the disjunctive items, then we have automatically denied it the other disjunctive part. Example, either A is true or B is true. A is true, so B is false. Divine. You raised your hand.
Yeah, hello, Doc.
Yes, so
Please, it's a
I
mistake.
thought Devon's hand was raised.
It's a mistake.
Either A is true
It's
or
a
B is
mistake.
true. Okay. All right. Okay. Either A is true or B is true. Either A is true, B is true. A is true. Either A is true, B is true, or either A is true, B is true. B is true, so A is false. So this is what we call a disjunctive argument. It rests on an either or premise. Let's put it in words. Either I became a reverend father or I got married. Or either I became a reverend father or I got married. I became a reverend father, so I did not get married. So now it's time to relax with a little exercise. Determine what kind of argument this is. Determine what kind of argument this is. Anytime he goes to town, he passes by my mother's house. Anytime he goes to town, he passes by my mother's house. Today he passed by my mother's house, so he went to town. Anytime he goes to town, he passes by my mother's house. Today he passed by my mother's house, so he went to town. Determine what kind of argument it is. So I've given you some steps for determining the kind of argument. First of all, find out what is a major premise. Which one is the major premise? I told you the major premise is the one you can convert to a conditional, an if and then statement. That's the premise that is, I call the major premise. When you have identified the major premise, then the first part of the major premise is the antecedent, the second part is the consequent. So you have to ask yourself what the minor premise is doing. What is it doing? Is it referring to the antecedent or the consequent? And in what way is it referring to it? That's how you find out what kind of argument this is. So I'm giving you 2 minutes to work it out. 2 minutes to work it out. Find out the major premise, then find out the antecedent and consequent. And then that will tell you what kind of argument it is. Okay, so I'm going to take it up myself. So listen carefully to know how to find out the kind of argument. The first step is to find out what is the major premise. To find out the major premise, you need to find out the one that you can convert to a conditional. Today he passed by my mother's house. Today he passed by my mother's house. You can't convert that to a conditional. Anytime he goes to town, he passes by my mother's house. So I think, in fact, the first step is to find out what are the premises and what is the conclusion. Which are the premises and which one is the conclusion? When you find out, then among the premises, which is the major and which is the minor? So those are the two first steps. One, which one is the conclusion? Obviously, the conclusion is so he went to town. So he went to town is the conclusion. That means that the first two statements are the premises. Now, among the premises, which is the major and which is the minor? The major is the one you can convert to a conditional. Anytime he goes to town, he passes by my mother's house. So that already looks like a conditional. So to make it a perfect conditional, you just rework it with if and then. So if he goes to town, he passes by my mother's house. If he goes to town, he passes by my mother's house. If he goes to town, then he passes by my mother's house. Then he passes by my mother's house. So that's a middle. So that means that going to town is the antecedent. Passing by my mother's house is the consequent. Going to town is the antecedent. Passing by my mother's house is the consequent. So the question is, what is the minor premise doing? Is it affirming or denying the antecedent or consequent? Today he passed by my mother's house. Today he passed by my mother's house. That affirms the consequence. Today he passed by my mother's house. That affirms the consequence. So that means, and then that's an invalid argument. We said, according to the rule for deductive reasoning, affirming the consequent leads to an invalid conclusion. So it is an argument that affirms the consequence. So that is what it is, an argument that affirms the consequent. Okay, so let's answer this correctly. We have about 4 questions here. Answer correctly. We deduce correctly when we deny the antecedent. We deduce correctly when we deny the antecedent. True or false? We deduce correctly when we deny the antecedent. True or false?
False.
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 False. Yeah.
We use affirm the antecedent. That should be true. Because affirming the antecedent leads to a valid conclusion. Then number 3. Yeah, Mutua, you are raising your hand. Angela Mensa, your hand is raised. Okay, so we said number 2 is true because it affirms the antecedent. Number 3, we deduce correctly when we deny the consequent. Number 3, we deduce correctly when we deny the consequent. True or false?
True.
That's correct. When we deny the consequent, we deduce correctly. Number 4, we deduce correctly when we affirm the consequence.
False.
False, that's correct.
False.
That's correct. Yeah, that's correct. So let's move on. Now let's look at validity versus soundness. Validity versus soundness. So now we have understood validity. There are only 4 valid arguments. Only 4 valid arguments. A modus ponens, a modus tollens, a hypothetical syllogism, or a disjunctive syllogism. So we've only 4 kinds of valid arguments. Any other one is invalid. So the 4 types of deductive syllogism are 4 ways of making deductively valid arguments. A valid argument is an argument whose premises are logically consistent with its conclusion. The premises of a valid argument necessarily imply its conclusion in the manner that it is impossible to deny the inference without running into self-contradiction. An invalid argument is an argument whose premises do not logically imply the conclusion. The relationship between the premises and the conclusion is not that of logical necessity. You can proceed to the conclusion of an invalid argument without contradicting yourself. Now, the formal fallacies are invalid arguments. So those fallacies we saw, we call them formal fallacies. Denying the antecedent is a formal fallacy. Affirming the consequence is a formal fallacy. The two types of hypothetical fallacies are formal fallacies. So the 4 of them are formal fallacies. We call them formal fallacies. From next week, we're going to be seeing informal fallacies. So you can compare the formal fallacies to the informal fallacies. But any fallacy committed in a deductive reasoning is called a formal fallacy. Now let's look at valid but not sound. An argument could be valid but not sound. All human beings are immortal. All human beings are immortal. Peter is a human being, therefore Peter is immortal. All human beings are immortal. Peter is a human being, therefore Peter is immortal. This argument is valid because it is a correct modus ponens. It affirms the antecedent, so it is valid. But it is not sound because one of the premises is not true. So there is falsehood in the argument somewhere. So we say it's not true. It is valid, but it's not true. Now, because it is valid but not true, we'll say it is not sound. It is valid but unsound, or valid but not sound. Another example, all men are mammals. All mammals must get killed. All mammals must get killed. Therefore, all men must. Therefore, what kind of argument is this? All men are mammals, all mammals must get killed. So men is A, mammals is B. So all A are B, all B are C. Therefore, all A are C. This is a hypothetical argument. All A are B, all B are C. Therefore, all A are C. Hypothetical syllogism. So that means it's a valid argument. A hypothetical syllogism is a valid argument. But is it true? No, it's not true because it's not true that the premise 1 is false. So it's not true. So it is a valid, but it is not a sound argument. Valid, but not sound. You can have invalid argument with true conclusion. Invalid argument with true conclusion. Democracy is better than other forms of political organization because citizens in a democracy are holier than citizens in another form of political organization. Democracy is better than other forms of political organization because citizens in a democracy are holier than citizens in another form of political organization. So first of all, we need to break down this argument. There's a conclusion and there's a premise. Now, you can see that there's a conclusion and there is also a premise. So this is an example of an argument where the conclusion and the premise is in one sentence. First of all, it is a single premise argument. It is a single premise argument. It has just one premise, not just that the premise and the conclusion are combined in one sentence. And then in addition to that, the conclusion comes before the premise. So democracy is better than other forms of political organization is the conclusion. And then because citizens in a democracy are holier than citizens in another form of political organization is the premise. So the premise comes first. Sorry, the conclusion comes first. The premise comes after that. Now, is the conclusion true? Yes. We all believe democracy is better than other forms of political organization. So the conclusion is true. What about the premise? Is the premise true? Because citizens in a democracy are holier than citizens in another form of political. So we don't believe, nobody believes that is true. So the premise is false. You have true premise, you have true conclusion and false premise. So this argument is invalid, but it has a true conclusion. Now, the true conclusion alone does not make an invalid argument correct. True conclusion alone does not make an invalid argument correct. So let's look at valid and sound. Valid and sound. To be sound, all the premises in a valid argument must be true. All men are mortal, Peter is a man, therefore Peter is mortal. So it is valid because it affirms the antecedent. It is true because all the statements are true, all the premises are true. So we say it is valid and sound. So we have three forms. We have valid and sound, valid and unsound, and then we have invalid and unsound. Valid and sound. All snakes are reptiles. That's true. Cobra is a snake. That's true. Therefore, cobra is a reptile. Now this argument is valid because it follows the correct rule for deductive reasoning. It affirms the antecedent. So this is an argument that affirms the antecedent. Cobra is a snake affirms the antecedent. So it is a valid argument. Is it true? Yes. All the premises are true. So the argument is true. So because of that, we say the argument is valid and sound. Valid but unsound. All snakes are reptiles, which is true. Mosquitoes are snakes, which is false. Therefore, mosquitoes are reptiles. So it is valid because it affirms the antecedent. Mosquitoes are snakes, affirms the antecedent. So the argument is valid. But it is unsound because one of the premises is not true. Mosquitoes are snakes is not true. So the argument is valid, but it is unsound. You can have both invalid and unsound, which is a double jeopardy. All snakes are reptiles is true. Mosquitoes are reptiles is false. Therefore, mosquitoes are snakes is false. So the argument is invalid because it affirms the consequence. It affirms the consequence. So it is invalid. It's also unsound because one of the premises is not true. So the argument is both invalid and unsound. Is an invalid but sound argument possible? No. An invalid argument is unsound, even if the premises and conclusion are all true. All Ghanaians are Africans. Kofi is an African, therefore Kofi is a Ghanaian. So the argument is invalid. So that also on sound. It is that all Ghanaians are Africans is true. Kofi is an African is true. And Kofi is a Ghanaian could also be true. All of them could be true, but still the argument is invalid and therefore unsound because it affirmed the consequent. You don't determine that Kofi is a Ghanaian by determining that he's an African. That's not, it's not a sufficient reason. It's not a valid pathway. Or let's say it's not a valid logical pathway. And remember that this is called deductive argument. Deductive argument. You cannot deduce that Kofi is a Ghanaian from the statement that Kofi is an African. When you say Kofi is an African, you cannot from there deduce that Kofi is a Ghanaian because there are so many African countries. So let's look at the technicalities. Validity is needed for soundness. Validity is needed for soundness. What you need for soundness is both validity and truth. Now, but soundness is not needed for validity. Something can be valid and is not sound. So soundness is not needed for validity. Some arguments are valid but not true. Now, soundness needs both validity and truth. Okay, so let's do a little exercise before we call it a day. Identify the missing premise in each of the following deductive arguments. Now, there are supposed to be 3 statements, or there are supposed to be 2 premises, but you have only 1 premise at the conclusion. So what is the missing premise? All military men play football. Bob plays football. What is the missing? Someone can answer that. So you can raise your hand and tell us the missing premise, or you can just open up your microphone and answer the question. All military men play football. Bob plays football. There's a missing premise. What is it? I've already told you how to find a missing premise. So you just look at how many times each of the concepts were used.
So Bob is a military man.
Bob is a military man. That's correct. Bob is a military man. That's correct. All Americans are human beings. All Americans are mammals. All Americans are human beings. All Americans are mammals. What is the missing premise?
Sir, all human beings are mammals.
All human beings are mammals. All human beings are mammals. That's correct. So you just get those terms that have occurred only once. And that tells you the missing statement. Answer correctly. Which fallacy is committed by the following? All A's are C's, all B's are C's, therefore all A's are B's. All A's are C's.
So the second type of hypothetical fallacies.
Yeah, the second type of hypothetical fallacy. So all Ghanaians are human beings, all Africans are human beings, or rather, all Ghanaians are Africans, all Kenyans are Africans, therefore all Ghanaians are Kenyans. So that's correct. Describe the following arguments. All Europeans are not my friend. Ben is not a European, therefore Ben is my friend. Or look at the second version. No European is my friend. Ben is not a European, therefore Ben is my friend. What kind of argument is it? Remember that two negatives combine to make a positive. Two negatives combine to make a positive.
So it's an invalid argument.
Yeah, but what kind of invalid argument?
Fallacy of affirming the consequence.
Yeah, so that's when you look at the first version. Look at the second version. If you look at the second version, then you wouldn't be so sure of the first one. But both of them are the same. And the second version is a more accurate way of presenting it. No European is my friend. Now, no European is my friend is more accurate, is clearer than all Europeans are not my friends. Whether you are dealing with the first or the second version, you can see that the argument doesn't have to do with the consequence. The argument is dealing with the antecedent, because the antecedent is European and friend is consequent. Secondly, we said that two negatives combine to form a positive. So no European is my friend. Ben is not a European. Now, the first premise denies the antecedent, Europeans. The second premise also denies the antecedent, Europeans. So when you have two deniers, it means that the second denial is affirming the first denial. So it's an affirmation, not a denial. So what you say is that the second premise is affirming the first one. It's not denying it, because both of them are deniers. So one is an affirmation of the other.
So please, this
So you
sentence
say
is
that
valid.
Yeah, so you say that this is an argument that affirms the antecedent. So it's a valid argument.
Okay.
Once you are sure that it affirms the antecedent, then you can be sure it's valid. So to repeat what I said, the first premise denies the antecedent. No European is a denial. The second one also denies the antecedent. So both deniers of the antecedent means that one denial is an affirmation of the other denial. Two negatives give you a positive. So we shall be doing inductive reasoning next week. I will take a few questions, and I would advise you guys to watch the recording. I'm reasonably expecting that I'll be able to retrieve this recording, because I retrieved the recording of the last class I held with this particular link. So I think it will come in, and then I'll upload it online and send you the link for watching it. Now, is there any question with regard to a particular place. Any question with regard to a whole section or even the whole class, you would have to go and watch the recording, because we can't repeat the whole class or the whole of a section, But if you have a particular concern about one particular thing, then you can ask it and we'll clarify it. Okay, so I'm anticipating that by tonight, by the end of today, or probably tomorrow, you'll be able to get the link to the recording of the class. So now I'm going to stop the recording. I'm stopping the recording so that I can retrieve it, upload